Alright, so I wanted to go ahead and make another video just kind of walking you through what I did in class so you can kind of see some of my thought process when coming up with the structures for molecules. So here we're going to try to do the phosphate ion, so PO4 with a 3 minus charge. So I went ahead and wrote out the phosphorus and the 4 oxygens. That is all what it would look like if it were neutral. Well, I have to add 3 minus to it, so I'm going to go ahead and add 3 extra electrons into the pool. So I'm just going to put them all on different oxygens. And like I said in class, when I am looking at this now, I always start with the oxygens, or not the oxygens, the atoms that have one single and ready to mingle electron. Okay, they only have one electron that's open for bonding here. So I know each of those is going to make one bond, so I'm going to go ahead and place those. I'm going to say, we got to go ahead and do this. Okay, and then I have 2 electrons left over, so all of these are now taken care of. I have 1 oxygen. I have to bond this oxygen, and the oxygen wants to make 2 bonds if possible. Well, phosphorus does have 2 electrons, so let's look at what if we just did this. Both of those electrons go ahead and bond. And then we got our phosphate. Well, looking at formal charges, for this one we'd have a 0 formal charge, this one, -1, -1, -1, and 0. That means it all adds up to be -3, which is what we need. The negative formal charges are on the most electronegative element, the oxygens, so that's good. And I got 2 zeros still, which is good. So how would we know, looking at this, there is another option. And we've talked about coordinate covalent bonds before. What would happen if those electrons did a coordinate covalent bond and just bonded, they gave those electrons to the oxygen, and the oxygen kept all of its electrons, like that. Okay. Now, if you'll notice, phosphorus actually has an octet. It didn't before. It had 10 valence electrons because it had 5 bonds. Now it has 8. It's got an octet. Woo! Isn't that supposed to be what it's like? Well, if you do the formal charges now, phosphorus actually has a +1 charge, and all these have a -1. That still adds up to be -3, which is what we want, but we don't have 2 zeros anymore. It's not as good. So the other way is actually the preferred way to do this structure. Now, you're like, well, phosphorus has 10 valence electrons. Yes, there is the possibility for expanded octets, and we talked briefly about this. And typically, what happens with expanded octets is the atom that we're looking at, the central atom, is either going to make as many bonds as it has single and ready to mingle electrons, or it is going to make as many bonds as it has electrons. So for instance, phosphorus has 5 valence electrons. So in this case, it made 5 bonds and it works. What that does, when we make as many bonds as you have valence electrons, that still allows you to get a 0 formal charge on that central atom. And that's what we're looking for most of the time. So hopefully that's a little bit helpful. In this case, now, we have 4 groups around the central atom. The furthest apart 4 things can get is the tetrahedral shape. So I'll go ahead and it is tetrahedral because the phosphorus does not have any lone pairs of electrons. So I'm going to go ahead and take that and like this. And there we have it. That would be tetrahedral. Remember, the dashes go into the page, the wedge comes out of the page. I don't really care whether you fill in the wedge or not. Alright, let's go ahead and do one more while I have it here. You can, stop the video here if you feel good about it all. but let's do ClO4 with a -1 charge. This is the other tricky one from the homework. So all of my oxygens would look like this. My chlorine like this, okay? And I have a -1 charge, so I have to add an electron. And like I said, I'm going to do the atoms that have just 1 electron ready to bond first. So we can go ahead and say the chlorine is attached to the oxygen like that. So this one's taken care of. Now I have to bond all 3 of these oxygens. Each of those would like to make 2 bonds if possible, but we have to take formal charge into account. Well, if we went ahead and bonded each of those 2 single electrons with each of these single electrons like that, it would end up that chlorine had 7 bonds total, 3 double bonds and a single bond. Well, formal charge would then be 0, and that is good. So in this case, we can actually go ahead and do one of these numbers. And this has a 0, this has a 0, this has a 0, this has a 0, and then a -1. So it's -1 overall. We got mostly zeros going on there. The most electronegative element has a -1 charge. Now, like the phosphate, which I didn't mention before, this one would also have resonance. Who's to say that it's the right bond over here that's always got to be the single bond? It could be any of them. And so you have resonance forms where any one of those could be the single. Well, if I had done coordinate covalent bonds here, the chlorine would have had a +3 charge, and then each of these oxygens over here would have had a -1 charge, which would still add up to be -1 overall, but the formal charges would not have as many zeros. So once again, just like the last one, we have 4 groups. So I'm going to go ahead and work out my tetrahedral structure. And when you have a double bond that's got to be a wedge, I typically just go like this. I don't know if that's the right way to do it or not, but that's what I do. So this one over here is the one with the -1. And there you go, tetrahedral. So that's kind of my thought process. I hope that helps. And just, we got to keep practicing on